Jai Hind. The topic which we are going to cover today is algorithm examples. We have already seen what are the algorithm, how to create an algorithm with if-else construct and for the looping. But first two algorithm I am presenting just for the revision purpose. They are very simple algorithm. Later on we will see that how to write the algorithm for a complex problems. So basically the very first algorithm, it is a very simple algorithm which is saying that is how to find the largest of three numbers. And if we say a largest of three numbers, then basically if I am having three numbers A, B, C, then I need to find which one is the largest. So for this, what I need the if-else construct, that is decision making is here. So this particular slide is showing that is how we go if we are having such decision making in our program, how to write the algorithm for such things. The input is we are having three variables A, B, C, integer type. So start, and then we will read these three inputs. Here we are using if construct basically. So we are checking if A is greater than B and A is greater than C, then we say it is maximum is your A. Similarly, in next two steps we are checking the same thing with the variable B and C. So if we are saying if B is greater than A, then C is equals to B, and in the last what we are doing, we are printing the C here. Sorry, this step won't come here basically. So we are saying that then max is C, and here what we will do, we will print either A, B or C depending which is maximum in out of 3. This is how we when we use the if construct. But what happen if we use the if else, then how we write the things. For this, if I am saying step 1 is same, step 2 is same, in step 3 I am saying if A is greater than B basically and A is greater than C, then what we say, then print. We can go with the print command in the statement itself, then print A. Else, if again we are checking with B and with the variable B, B is greater than A and B is greater than C, then print B, and with if this else, print C. Why we are not checking with the third condition here? Because what we have done, we have matched if with this else. If this condition is true, okay, then we will print A. Otherwise, we will go with this condition. If this condition is true, then it's okay. Otherwise, we will go with the third condition, and third condition, if this is not true, if this is not true, automatically this is going to be true. So in that case, with the last else part, we have not given the condition, we are just simply giving else part, else print C, and the last step is going to be stop. This is how you can make the if you are having decisions in your program, then how you write the algorithm. You can use the construct if, as well as you can use the construct if else. Also you can go with the nesting of if else. Now in this example we will see that is if we encounter a loop in our algorithm, then how we write the algorithm. It is a simple algorithm for writing the factorial of a number. So in this case what we are having input n, we are checking, we have to initialize two variables. One is factor and another one is counter, and we initialize these two variables with 1. Now how to give the loop? This is one of the way. That is, here what we have used the while operator. So here in this case, while counter is less than or equal to n, then what? This is another important operator which we use here, that what steps need to be repeated. So in this case, what we are having, we need to repeat the steps 5 through 5 and 6. Sorry, this is 6 and this is 7. So 6 and 7 basically. So here we are having step 6, that is factor is equals to, we are computing a factorial, and then we are incrementing the counter variable, and in the last step what we are doing, we are printing n and factor. This is one way how to go with the for part. So these steps will remain the same. In step 5, what we do, for counter, here we don't need to give this step when we are giving the for part. For counter is equals to 1 to n. Okay, then repeat steps, that is whatever you want to, how many the number of steps you want to repeat. So here repeat steps 6 and 7. Again 6 and 7, they are going to be same in this case. This is with the for loop. Sometimes we use the until statement also in the for repeating the loops. So how we use here, again when we use the while, we need this until construct, that at that time we need this initialization part, that is the loop initialization variable counter. So here repeat, we will start with the keyword repeat steps 6 and 7 until your counter is less than or equal to n, and then these steps will remain the same. This is how you will use the, give the looping part. So either you can go with this construct, you can go with this construct, or you can go with this construct, but every time you need to give the number of steps which you are repeating. Now this is a algorithm. Here we have used the both things. We have used the if part as well as we have used the for part, that is for decision making, and this is for my looping construct. Here I am generating a Fibonacci series up to a given number of terms. So what is my input? The number of term, that is n. This is my input. So here I am starting, and then I am going to initialize the first two terms of my Fibonacci series, that is 0 and 1. For those who are not aware what is a Fibonacci series, in the Fibonacci series, the ith term is equals to the sum of I, that is the previous two terms. Okay, so here what will happen, when I can start only with F3, so I need F2, I need F0 and F1. So in this series, the first two terms are always your 0 and 1. So here I need to initialize them, that is 0 and 1, that is 0, 1, then it becomes 1, then it becomes 2, then it becomes 3 and so on. So this is my Fibonacci series. So first two terms I need to initialize, these are my base conditions. Always remember that whenever you write an algorithm, and if you are having a base condition in an algorithm, then give it in the initialization part. So if n is greater than 2, then what will happen? Then we will go to this step. Otherwise, what it is signifying? It is signifying that we are having this term onward. So I am checking this condition. Else, if n is equals to 1, that is only one term is required, then we will display only F0 and we will stop. This is important. Why? Because in this case we are saying then go to step 4. Now in step 4 I am doing certain calculations. Maybe sometimes what will happen, that after this calculation are having certain steps over there. So if you don't give the stop statement here, then automatically the statements present here would get executed. So to stop such kind of ambiguities, what you should do, you should give the stop there itself. Whenever you need to stop your algorithm, give that stop statement over there. So here stop else, that is what it says, that is we are having n equals to 2. This else implies that we are having n is equals to 2. Then in that case we need to display the first two terms. So here we will display f0 and f1 and then stop. Now if n is greater than 2, then what it imply, I need to repeat this step. So what is happening here, I have given the loop part, that is for I from what is happening 2 to n minus 1. Here you can use the from keyword, or you could give the equal to statement also. So here we are repeating the steps 5 and 6. In these steps we are calculating the next term, that is fi is equals to fi minus 1 plus fi minus 2, and then it is a series, so we are appending fi to the series, or you could say display fi. This will also work. And then when this looping, when this series got printed, you will stop your algorithm. This is an algorithm where we are finding the sum of 3-digit number, that is if I am having 5, 2, 3, then this imply 5 plus 2 plus 3, so it output comes out to be 10. So we are displaying this sum of digits of a 3-digit number. So we are starting with the start part, then we need a variable sum in which we are storing the summation part, and we have initialized it to 0. Then we are repeating the steps up to when we are repeating the steps while num is greater than 0. So here what we are doing, we are extracting the last digit, that is digit is equals to num divided by 10. We are getting a last digit which we are storing in the variable digit. Then we are adding the digit to the sum, that is sum is equals to sum plus digit, and then we are removing the last digit from the number, that is num is equals to num by 10. So here again what is happening, your number got reduced. So what is happening basically, if I am having 523, then in the digit part, in the very first step we are extracting 3, then we are adding, that is 0 plus 3, and here we are dividing, since num is my integer variable, so here when I am dividing with the 10, so what I am having, I am having 52 in this case. So we are repeating these 3 steps. Once these 3 steps, that is when this loop got terminated, and this is my termination condition. So after when the loop got terminated, we will output the value. We can also write display or print sum and then stop the loop. This is a algorithm where we are determining whether there is a 3-digit number ABC, where ABC implies ABC is equals to, that is this 3-digit number is equals to, that is we are extracting these 3 digit, we are finding the factorial of these 3 digit, and then after finding the factorial we are doing a summation part, and then we are checking whether this sum is equal to this digit or not. If this is equal to this digit, then we are displaying that number. So here we are determining whether a 3-digit number exists which follow this particular property. This is the property which we are checking. So here we will write an algorithm for this particular concept. So the input is, no input is needed since we are testing all the 3-digit numbers. So in this case, so this is particular example is showing that sometimes we are not giving input from the user end. So here we are starting, and then we will go with the second step, that is initialize. In the initialization, what we are doing, sometimes in algorithm we need the pre-computed part. So in this case we are having a pre-computed part. So we are pre-computing the factorial, that is, this is a function which already have been written and which we have seen earlier, that is how to compute the factorial of a number. So in this case, what we are finding the factorial only of these 10 numbers, we are finding the factorial, and we are storing these in an array. Okay, so at the ith index, what I am having the factorial I. Now in the next step, I am repeating the steps, and since it is my 3-digit number, so this is my starting point and this is my termination, last point. So here I am initializing and here I am terminating my loop. Here I am extracting the digits. We have seen earlier that is how we are going to extract the digit, but the thing is that here I am extracting the digit separately in 3 numbers. Why I am doing so? Because in this case I need these 3 numbers. So I am storing A, then I am storing B, and in the last I am storing C. That is, I am separating, or you could say in these steps what I am doing, I am separating my, if I am having 25, so I am separating 3, 2 and 5 as A, B and C. After that, what I am doing, I am computing the factorial. So in this case, this is already pre-computed, so I am getting these results directly from here, and after that I am finding the summation. If this sum is equals to my original number, so we are saying display num, otherwise we will again repeat the steps until we reach this termination condition. So in this, what we have seen, this particular example is having both decision as well as looping part. How to find the addition of 2 matrices? We are having input. Here I am saying I am already having 2 input matrices. I am initializing 2 variables I and j, and in this this particular example is showing that is how to take the nesting of loops. Okay, in the if else, in the previous example we have seen that is if we are having the nesting of if else, how we go with it. In this example, what we are saying that is if we do the nesting of loops, then how we carry on with the algorithm part. So here I am saying repeat steps statement 4, that is this, until I is less than 3. In the fourth, I am saying repeat statement 5 until j is less than 3, and in this what I am saying, I am computing, that is storing, C is my output matrix, and here I am storing the addition of 2 values which are present at ith and jth location. Now this particular part is only to handle the addition part. I need to display also. So once I am displaying the things, again I need a loop, 2 loops. You could say 2 nested loops for displaying my result. In this case, I can't directly display the result. So here I am again using the nesting of loops, but before that I need either you take a separate different variables, for example A or B. If you are taking the same I and j variable for your loop, then in that case you need to initialize it to 0. So in the 6th step I had initialized it to 0, and then again the same thing, this is the nesting, so I am saying repeat this statement, this is again saying that repeat statement this, and I am displaying the matrix part. So this is how the algorithm to add 2 matrices has been written, and how to display the output. So sometimes if in your program part we are having a you could say we need to display the things repeatedly, then again you need the loop just for the displaying part. This is simple how this particular example is being used, that is if we need to show the function. So if you in an algorithm, so here I am having the find the maximum element in the given array, and this is my function basically. So and I can call it in my program when I am writing certain program. This is how to write the algorithm when for a function. So here my function name, I need the function name. So this is my function name and my argument part, what need to be passed on. So in this case, it is my matrix. So these three things are showing your comments. So determine the value of the largest element in a given array, an array of real numbers, and what is the output, the value of the largest element in your array A. And here this is my first step, that is we are initializing A0 with the max value. Then for I 1 to n minus 1, this is another thing. You can use the do construct, or as well as you can use the repeat construct. If ai is greater than maxwell, then what will happen? Your new maximum value will become this, and then after once the maximum value has been computed, we are returning this maxwell. So this is how you write the function in an algorithm. This is another function where we algorithm for a function. Here what we are doing to check whether all the elements in the given array are distinct. So here my array name is my unique elements. This is my input, and what is my, it either returning true if all the elements A are distinct, or false if any one of them is matches with the other. So here what is happening? I am having the nesting of loops. Okay, so this is my initialization part, 0 to n minus 2, whereas my inner loop, it will start from I plus 1 to n minus 1, and here I am checking the two values of my array ai and aj. That is, we are first checking with 0 and 1, then we are checking 1 with 2, then with 2 and 3, and so on. So if ai is equals to aj, that is if any one of them matches, then automatically we don't need to check further. So here I have used the return statement here itself. So it is acting as a stopping kind of thing. It is serving as a stopping criteria here. Return false, otherwise it will go on and on, it will check all the elements, and after that it will return true. So this is a function algorithm for a function where we are checking whether all the elements in the given array are distinct or not. So these are the few examples which we have discussed today, which are showing, that is, if we are having a complex problem, then how we will write the algorithm when some loops or decision making involved, as well as this lecture also discussed, that is how to write an algorithm for your functions, because this is also very important, and how to call them. Since in my code, for example, in my algorithm, that is my main algorithm. Suppose I am having main algorithm. So in that, the very first step is a start. Whatever I need to do, I will doing that. Suppose on nth statement, I am calling this function, that is unique elements. And here, for example, I am having 10. I am having array of 10 variables. I am just calling here, and then in the n plus 1 statement, what we are it is returning true. So here I need to store my returning variable in some variable. So here I use the variable, for example, boolean. So boolean is equals to unique element, and passing my you could say my array here, and after that display boolean. So whatever return it is returning, true or false, on the basis of that I am displaying my result, and the last step says stop. This is how we call a function in the main algorithm. So this is all for today. Thank you and Jai.